Hello and good day again everybody, welcome again to another video lecture, and for this lecture we would now be discussing about the total hydrostatic pressure. So in this particular topic we would now be having two main formulas, which are the following. So we have our force P and the location. So we have a new term called eccentricity here. So as for the force P, this is basically gamma bar HA. So this is the formula that we will be using. So memorizing this formula is very similar to the formula that I have discussed in the previous video lecture that I have posted, because in the previous video lecture, so given a certain depth of liquid, if you want to know the pressure at this particular point, just multiply the unit weight times the gravity times h, or this particular height, or basically rho gh. And if you can remember, rho g is basically equal to gamma, or unit weight. So that is, this collectively is the same with gamma h. So this is now gamma h, and we would just be multiplying the cross-sectional area, or the area of the plate itself. So that is for the force P. So that is for force P. And as for the location of that particular force, we have this term which we call eccentricity. And when we say eccentricity, it is the distance from the centroid of the plate up until the center of the pressure. Okay, so for you to better understand that concept, it is better if we would be having a certain, let's say, a figure. So suppose that this is now a body of water. So let's say that this is now the water. And let's say that there is a plate submerged. So let's say that that plate, or that particular plate, is this one here. So let's say that this is now the plate which is slanted. Okay, so this is the side view of the plate, and let's say that its front view would now look like this. So let's say that this is now its front view, or the front view of the plate. Okay, so once again, this is the front view here. So front view, and this is now the side view, which is slanted. Okay, so since this is the side view, we have plenty of parameters that we should take into consideration. So for bar h here, so for this particular formula, where P is equal to gamma bar HA, and as per defined here, gamma h, or h bar is the distance from the center of gravity below the liquid surface. So since this here is a rectangular plate, we can conclude that its centroid is, well, basically at the center. So if that is now the centroid, as per defined earlier, that for bar h, that is the height from the fluid up until the centroid. So let's say that this is now the centroid of that particular element. So this is now bar h. So this is now bar h. So what about for A? Once again, let's say that the front view of this, or let's say that this plate is this before it was slanted. So let's say that this is its original figure before it was slanted. Well, actually, kahit hindi pa nakaslant, basta yan mismo yung total area ng plate na yan. So for that particular plate, that is basically base times height. So this area is dependent upon the shape of the plate itself. So if your plate has a star section, or a star shape, then you must know how to determine the area of a star. So if it is a trapezoidal plate, then you must know the area, or you must know the formula in getting the area of a trapezoid and whatnot. And of course, you need to know the property of this particular fluid. So in this fluid, so let's say that this is now fresh water. We can conclude that our gamma, or our unit weight, is equal to 9.91 kilonewtons per cubic meter. So with that, we can now solve for the pressure P. Okay, so for the pressure P, actually that is force P, I should say. So for force P, its location, or its force, is now directed perpendicular to the plate. So since this is the plate, let's say that this is now that particular force P. So ito na po yung force niya. But as you can see here, hindi po siya eksakto dun sa centroid. So its force is not located at the centroid, which we computed a while ago for bar H. So where is this located? So this is located a distance below. So it is always below the center of gravity. So the distance from the centroid, up until this particular resultant of the pressure is what we would be calling our eccentricity E. Thus, E. So as for our eccentricity E, it is given by the equation the moment of inertia divided by the area of the plate times bar Y. Take note, this should be bar Y and not bar H. As for their differences, if you would be going back here, so bar H is the vertical distance from, once again, from this point or from the top of the fluid up until the center. So it must be vertical. And as for bar Y, so ito po hindi ko na nailagay yung bar sa part na to. It is the distance from the center of gravity below the liquid surface along the body. So if the body is slanted like this one here, in order for you to get the value of bar Y, it must be measured along the body. So if it is slanted, your measurement must also be slanted like this. So ito po siya. So this particular value, so from this point up until the top portion of our fluid, that is now our bar Y. So this is now our bar Y. Ayaw masulat. So this is now our bar Y. So that is for bar Y, and as for A, same old. So this is still the area. And as for the moment of inertia, so this was discussed from statics of rigid bodies. So these are the common shapes, but are not limited to, of course. So we have for rectangles, the moment of inertia about the x-axis is equal to bh cubed over 12. So in this case, since this is b and this is h, so b h cubed over 12. So if it is now the other way around, so let's say that this is now the shape of the plate, whereas the base is larger than its height. So same thing. So if this is now b and this is h, the moment of inertia is still bh cubed over 12. So ganyan pa rin yan, whatever the orientation of that rectangle is. Okay, so I also have this figure here, which shows us, how to solve for their respective areas and how to locate their centroid. So why do we need this? So for example, that instead of this one here, so instead of this plate here to be a rectangular one, so for pretend that it is now triangular. So kapag triangular po yan, so its center of gravity is not located along the midspan. Because as we know, that if you have a certain triangle, its centroid is located 2/3 from the top and 1/3 from the bottom. So it is located at this particular point. And this is now 1/3 and this is now 2/3 of the whole height. So ganon. And also we need, of course, to get familiar with this, since for example that we have a composite shape. So when we say composite shape, it is not one, or let's say that it is composed of multiple basic shapes together as one body. So that is our first example actually. So there. Okay, so for our first sample problem, the Utah-shaped plate shown is submerged. So I have erased this part because I have said here that it is submerged in water. However, I have modified this problem in such a way that it is not water, and I have introduced oil. So instead of water, it is now oil. So whereas the specific gravity of this particular oil is 0.82, and let's say that for this particular specific gravity, its reference unit weight of water is not 9.81. Instead, it is 9.79. So if it is given in the problem that it is 9.79, or the unit weight of the base water is 9.79, of course, we would now be making use of this and not the traditional 9.81. Okay, so in this problem, we would now be finding the magnitude of the hydrostatic force on one side of the plate. So let's say that this is now the plate. Of course, we would now be solving for the hydrostatic force, which is basically P or force P. So this is now the hydrostatic force. And of course, we would now be finding the depth to the center of pressure, then after which we would now be finding the magnitude of the hydrostatic force if let's say that this plate is lifted 1 meter upward. Okay, so for us, in order for us to solve for problem A, so find the magnitude of the hydrostatic force, so given the formula, P is equal to gamma bar HA. Okay, so in this, it is already self-explanatory that we must solve for the value of A or the area of this particular plate, its bar H or its centroid, and of course the unit weight. So let us solve for the unit weight first. So for the unit weight, so that this is basically the specific gravity, so multiplying specific gravity by the unit weight of water. And with that, this is now equal to 0.82 times 9.79. Okay, so it is either you will be solving for this, then storing it on your calculator, but better yet, if we would just be incorporating these values or this equation to our equation for hydrostatic force. And as for bar H, so bar H is the location, or let's say the distance from the top fluid up until the centroid of this particular figure. However, this figure is not a basic shape since we have here a Utah shape. So we do not have the formula for the Utah shape, for the centroid of Utah shape here, but of course we can solve for it using Varignian's theorem. So in Varignian's theorem, so I would just be moving this here. So according to Varignian, the centroid or the location of, let's say, the centroid of a certain entity given a certain reference point multiplied by A is equal to the sum of the product of the two, or of the area and the location. So let's say that this is now, this particular shape is divided into multiple shapes such as this. So let's say if you want it to be divided this manner. So let's say that this is now shape 1 and this is now shape 2. And with that, this or this bar Y or the total centroid, the centroid of that particular shape times the total area is equal to the area of the first one divided by the location of its centroid plus the area of the second one times the location of its centroid. Okay, so where is our reference point for y1 and y2? So the answer to that depends on to you. So if you want your reference point to be from the bottom up, that is your choice. But it is more logical if you would now be measuring them from, let's say, the fluid itself. So let's say that this is now the fluid. It is better if you would now be measuring it from this portion up until this, and this portion up until, of course, the centroid. Okay, so if you want it to be measured from this point up until this point, once again, we have no problem in doing that. However, make sure that, for example, that this is now your located centroid of that particular figure. If this is now, let's say, your bar Y, make sure that for your bar H, you would be measuring from this point up until the fluid, because that is what we would be using in this particular equation. So, ayun, choice nyo po yun. However, for the practicality of this review, let us now use this as our reference. Okay, so with that, we will be making use of a calculator technique for Canon 789 SGA. So, ito po yung available po sa Philippines na pwede pong gamitin sa board exam. But take note that in our figure here or in our calculator that we are using in this video, meron po siyang white, pati meron din po siyang transparent na editions. And according to Canon, ang locally available nila na lang is yung transparent. So hindi na po available yung kulay na to, but they have the same feature. Okay, so in order for us to solve for the centroid here, so for example, no, yung composite section nyo has total shapes of, kunwari, 5 or 6. So baka mahirapan na kayo mag-variance theorem. So as a shortcut, we would now be going to the statistics modes. Mode pala. Stat mode. So go to mode here. So click mode. Then click 3 or press 3 on your calculator. So this would now go to your stat mode. So madami po dito na parts or let's say marami po ditong methods ng stat mode. So we have SD, LIN, quad, log, exponential, and etc. So ano po ba yung mga yan? So in this one here, so these are the statistical calculation used by Canon 789 SGA. So the first one, SD. So as you can see on our calculator, yan yung SD sa pinakauna. Pangalawa is yung lean, pangatlo is yung quad, pang-apat is yung logarithmic, etc. So hindi naman tayo particular kung alon po yung gagamitin dyan, but ayun lang, gagamit lang po tayo ng kahit anong 2 variable para ma-maximize po natin yung potential. So we can use linear regression, we can use quadratic regression kasi hindi naman po tayo aabot dyan sa regression part. So ang gagawin lang po natin is i-manipulate natin yung basic parts niya. And when we say 2 variable, so kapag clinic ko po yung 2 dito, so meron po tayong dalawang column. So we have the X and the Y column. And once again, if you would be going to that feature, so click mode, then 3, so stat. And let's say that we would be having one variable statistic. So if I would be clicking 1, edi, ayan, edi 1 na po. 1 column lang po siya, so wala po siyang Y. But once again, for us to maximize the potential of this calculator in solving for Varenius theorem, so we would be clicking mode, stat, and we will be selecting any. So kahit ano pong 2 variables kasi kailangan po natin ng 2 columns. Okay, so I would be clicking 2 or yung linear po tayo muna. So 2. And of course, this interface would come out whereas we would be having 2 columns. So ang gagawin ko po, so kanya-kanyang diskarte, but in my case, I want the X values. So lagay ko lang po dito, note natin. For the X value in our stat mode, so lagay ko lang po pala dito, stat mode. So stat mode. So for X, so for the column for X, I would be using this for the area. And for Y, I would be using this for the location of the centroids or bar Y. So yung Y location po. Okay, so looking merely at the camera tuloy, at the calculator. So looking at the calculator here, this is now divided into 2 shapes. So meron po tayo shape dito. So we have here our first shape and our second shape. So for our first shape, teka, ba't nawala yung aking table? So if nawala yung table nyo, you can go back to mode, stat, then linear, or better yet, if you are already in stat mode, so it is already indicated here that I am in stat mode, just go to apps or applications, so apps, then 2, so the data, so that you can edit the data. Okay, so once again, for my stat mode, I would be making use for area for the X column, and I would be making use of Y for the Y column. Okay, so for X column, ano po ba yung area ng first figure natin? So that is basically equal to 3 meters times whatever this dimension is. And since collectively, all of this is 6 meters, tapos 3.5 meters yan, we can safely say that this particular dimension here is 6 meters minus 3.5. So 6 minus 3.5, so that is 2.5. So lagay ko lang po dito, no? So this is 2.5. So if that is 2.5, so going back to the stat mode, so ito yung table natin. So sa X, so for that particular area, that is 3 meters times 2.5 or 7.5. So that is for area number 1. For area number 2, that is basically 3.5 times 5. So looking at the calculator once again. So, ay, sorry, nawala. Isa pa. So for the next one, so 3.5 times 5 or 17.5. Okay, so for the second column, since dalawa lang po yung shape natin, okay na po tayo dyan. And for the second column, we would now be getting Y. So once again, it is up to you. I mean, it will be up to you if you want this as your reference line or if you want this as your reference line. So kayo na po bahala, pero mas practical po kapag itong nasa taas. Pero kung mas naintindihan nyo is yung baba yung reference point, so ulitin ko lang, it is okay as long as as soon as you have already located the centroid, subtract it from 7 meters para ito po yung makuha nyo. But once again, for our sample, ito po yung gagamitin nating reference point. So from the fluid down. Okay, so for the first object or the first shape here, its centroid is located here. So alam ko po yan. So alam po natin yan that for rectangular sections, the location of the centroid is located exactly at the center of that particular dimension or of that particular shape. So in here, it is basically equal to, so 1 meter plus 2.5 over 2. So lalagay ko na lang po dito. So 1 plus 2.5 over 2. So this is now the location of the centroid of the first shape. And as for the second shape, so for this particular shape here, so this is basically equal to, so 1 meter plus 6 meters. So 1 meter plus 6 meters. So it is this whole collectively minus 3.5 over 2. Oops, sorry. So this is now 3.5 over 2. So 3.5 over 2. Okay, so looking at the calculator to your left. So this is now equal to 1 plus 6 minus 3.5 over 2. So the location, oops, sorry. Once again, so 1 plus 6 meters minus 3.5 divided by 2. So 5.25. So yan na po yung mga gagamitin natin ngayon. Okay, so in here, we would now be making use of stat mode in order for us to solve for bar y. And ayun. Okay, so just merely looking at this particular equation here, we can now say that in order for us to solve for bar y, so bar y, so by cross multiplication, bar y is equal to area 1 times y1 plus area 2 times y2 divided by a, or the total area. So we can now make use of this equation for our calculator. So I would be clicking CA here and I will be going to apps. So apps, applications, and these are the features of the stat mode. Okay, so what I would be doing here is that, as you can see, that for A1 or for the area, these are the values for X. So this is now X1, this is now X2. And for the values of Y, basically Y1 and Y2. And collectively looking at it, this is basically equal to, or this can be rewritten as the summation of X1, Y1. Okay, so the summation of their products. So that is what it basically is. And as for area, since this area is the total area, or area is equal to area 1 plus area 2, and if there is area 3 and area 4, then of course we would be adding all of them. And in stat mode, we can conclude that A is the summation of X. So with this being taken into consideration, so our bar Y is now equal to the summation of X1, Y1, XY, I should say, the summation of XY divided by the summation of X. So ang gagawin po natin ngayon, once again, so if you are already in the stat mode, go to apps, then go to 4 or the summations. So go to 4, then hanapin nyo po dito yung summation ng XY, and that is basically 5. So click 5. So yan na po, summation of XY. And we would be dividing this by the summation of X. So apps once again, then go to 4, and go select the summation of X, and that is 2. And equal sign, so with that, we can now conclude that this is now, or our bar Y is now equal to 4.35 meters. Okay, so that is our bar Y already, or bar H. So the distance from this portion up until the centroid. So I would just be clearing all of this first in order for us to have a rather systematic approach, or rather a systematic solution. So this value, so let's say that this is now the centroid of our figure of our Utah ship plate. This distance is now equal to 4.35 meters. Okay, so with that, we already have the value for bar H, which is 4.35. And what about for the area? So for the area, that is the summation of X, as mentioned earlier. So for the total area, is now equal to 25 square meters. Okay, so for A, we can now solve for it directly. For A, we would now be solving for the total hydrostatic pressure P, or total hydrostatic force, I should say. And this is basically equal to gamma bar H A. And for gamma, as per mentioned earlier, that is equal to the specific gravity of the fluid times the unit weight of water. So 0.82 times 9.79. So 0.82 times 9.79 kilonewtons per cubic meter times bar H, and bar H is 4.35. And the area is 25. So the total hydrostatic pressure, so if I'm not mistaken, this should be 873.02. So looking at the calculator to your left, so that is 0.82 times 9.79 times 4.35 times 25. So this is now 873.02. So 873.02 kilonewton. So this is now for question A. Okay, so next up, find the depth to the center of pressure. So as mentioned earlier, that let's say that this is now the center of gravity. The center of the pressure, or the resultant of that particular pressure that we have solved for earlier, is not located along this point. And it is actually located a distance below it, or below the center of gravity. So let's say that this is now the location of, let's say, the center of pressure that once again we have solved for earlier. Oops. So moving this value, so moving this here. So let's say that this is now the center of pressure. So we have a distance, of course. And this distance is what we would be calling our eccentricity, E. And in order for us to solve for eccentricity E, it is given by the equation the moment of inertia divided by the area times bar Y. So the difference once again between bar H and bar Y is that for bar Y, or let's say for bar H, it is the vertical distance from the surface up until the centroid of the figure. And as for bar Y, it must be it must be parallel to the, or let's say along the direction of the plate. And coincidentally, since this plate is vertically upright, so vertical po siya, nakatayo po siya, yung kung i-measure po natin along its body towards this point, it is same as with bar H kasi naka-vertical po siya. Pero pag naka-slant po siya, of course, it must be measured in a slant manner. Okay, so with that being taken into consideration, we can now conclude that our bar H is also equal to bar Y. So bar H is also equal to bar Y. So same lang po sila. Okay, so in that particular figure or particular requirement, so we must solve for E, or the eccentricity E. And for eccentricity E, this is now equal to, once again, the moment of inertia divided by A bar Y. So as for the area and for bar Y, we have already solved for it in the previous requirement. So the only new thing here is, of course, the moment of inertia. So for moment of inertia, going back here, we have these formulas. So these are for basic shapes. So For rectangle, that is basically BH cubed divided by 12. But once again, since our figure here is a composite one, so meaning by composite, it is not really a basic shape, it is the combination of basic shapes. So with that, once again, we cannot make use directly of those formulas, but we will now be making use of the transfer formula. So for the transfer formula for moment of inertia, that is equal to, so I is equal to the individual or the summation of the individual moment of inertias plus, of course, our transfer formula, and that is also the summation of the area or the individual area times d squared, where d is the distance. So distance from the centroid to the individual centroids. Okay, so to the individual centroids. Okay, so with that, so let's say that this is now our figure. Ito po, let's say yung red po na yan part na ito, that let's say that that is now the centroid of the whole figure. And since we have divided this into two areas, meron po tayong figure, meron po tayong centroid para sa rectangle number 1, and we also have a centroid for rectangle number 2. So yung D po niyan, so in this case, so for yung una natin, the D is this value. And as for this, for yung object number 2 natin, it is now this value. So ito po yung D1, and ito naman po yung D2. Okay, so with that, we will now be editing our table in such a way that for our value for y, yan na lang po mismo yung mismong value natin ng d. Okay, so considering a while ago, no? So considering a while ago that yung linagay po natin dito is was measured from the surface up until the respective centroids. So eto. And na-solve na po natin na yung from surface up until yung centroid ng buong figure is yung 4.35. We can now say, since 2.25 itong nalagay natin kanina is this one here, we can now say that for D1, that is equal to 4.35. So ito, 4.35 yung na-solve natin kanina, minus 2.25, yung naka-highlight ngayon sa calculator. So 4.35 minus 2.25. So yan na po ngayon. Tama ba yung linagay ko? So, ito na po ngayon, 2.1 na yung distance natin for D1. So, ayan. And for D2, so kanina, yung yung distance natin from the surface up until the centroid of the second figure, that is 5.25. Kung nakikita nyo man po sa calculator nyo, 5.25 po dito. Ibabawas lang po natin. Ay, ba't natin ibabawas? So, yes, actually, ibabawas natin yung 4.35. Kasi 4.35 itong red, ang hinahanap lang naman po natin is itong D2. So, 5.25 minus 4.35. Once again, this is the distance from itong second area natin up until this particular location. So, yan na po ngayon. So, na-modify ko na po in such a way na yung value po natin sa X sa calculator natin, those are the areas. And for Y, yan naman po yung para sa, yan naman po yung para sa values natin ng D. Okay, and as for the moments of inertia, imamano-mano na lang po natin to. So with that, ito na po yung equation natin, no? So the total moment of inertia is equal to, so ito, may dalawa po tayong figures, and yung figures po natin are the following. So ito po, yung una, ang base niya is 3 meters and ang height niya is 2.5. So with that, so 3 meters po yung B niya. So ang base po pala natin dito, I is equal to, for rectangles, so of course, so this is now equal to BH cubed divided by 12. Okay, so B, that is 3, times H, that is 2.5, cube divided by 12. So ito po sa una. What about po para dun sa pangalawa? So sa pangalawa naman, that is 5 meters and 3.5. So plus 5 times 3.5 cube divided by 12. So yan. So plus the area. So ang area po natin dito is ayan, plus AD squared pala. So pwede po natin i-recta to sa stat mode. And in order for us to do that, i-close na po natin ito sa calculator. So click CA, then go to apps once again, then go to for or sum. So kung natatandaan nyo po that for A this is X and for Y this, for D that is Y. So this is basically the summation of X, Y squared. So hanapin po natin yan. And voila, wala dito. So yun, di ko in-expect na wala pala talaga. So since wala pong xy squared dito, ang meron po dito is x squared y, which is this. Pwede ba itong ma-down? Ayaw niya. So meron po dito is x squared y. Check ko nga lang po yung iba. So wala talagang ibang option. So with that, nagkamali ako dito sa paglagay. Mas maganda palang baliktarin natin in such a way na dapat yung d natin nasa x para magamit natin itong feature na nandito. So pagbaliktarin natin, so apps, go to apps, then go to data. Then ito pagpalitan natin yung 2.1 pati 7.5. So 2.1 lalagay ko dito. Lalagay ko dito 7.5. Tapos dito naman 0.9. Tapos ito naman 7.5. 17.5. So binaliktad ko lang po. Okay, so with that, hindi na po ito yung gagamitin natin. It must be the summation of x squared y. Kasi yung x na po natin is yung d. And yung a natin is yung y. Okay, so with that, lalagay ko na po dito lahat. So 3 times 2.5 cube. So yung cube natin dito. Divided by 12. Plus 5 times 3.5 cube. So shift cube divided by 12 plus the summation of x squared y. So go to apps, go to 4. Hanapin natin x squared y and that is number 7. Then yun, equal. So this is now our moment of inertia. So moment of inertia I is now equal to 69.02 meters raised to the fourth. So this is now our moment of inertia for this particular problem. Pero ang hinahanap naman po is yung location. So for the eccentricity, once again, this is equal to the moment of inertia divided by A bar Y. So you already have all of the unknowns. So substituting known values here. This is now 69.02 meters raised to fourth divided by what is the area once again. So I actually forgot. So the area nawala na. So for the area, wala. Hindi ko nailagay. Ay, dito pala, 25. So 25 yung area natin. So kung, para ma-solve natin, para ma-prove natin, di ba yung area natin is nasa y? So ups, sum natin yung y lang. So 4. So 25. So that is 25. And for barred y, so yung barred y natin guys, hindi na po itong d ha. Yung barred y natin is the distance from the surface up until yung centroid. And coincidentally, parehas po sila sa bar h. So bar y and bar h, iisa sila. So this is now 4.35. So this is now square meters and this is now in terms of meters. And with that, the eccentricity is now equal to, so 69.02, or actually, yung answer na mismo, ay wala na pala. So 69.02 divided by 25 divided by 4.35, sorry. So with that, our eccentricity is now equal to 0.635 meters. So yan na po ba yung sagot? Hindi pa po. So the answer here, so ang tanong kasi, find the depth to the center of pressure. So Since our eccentricity E, so yung nasolve lang po natin is this value, but the unknown here must be measured from the surface up until this pressure. So kung kanina man yung bar H natin, yung bar H natin is 4.35 or yung bar Y natin is 4.35, kailangan natin idagdag yung eccentricity. So with that, the location, so CP is now equal to, so center of gravity plus eccentricity. So substituting known value, so 4 point, ano na yun, 4 point, hindi ko na makita, 4.35 meters. Plus eccentricity of 0.635 meters. So the value of CP is now equal to, so looking at the calculator, so 4.35 plus 0.635. So our answer here is 4.985. 4.985 meters. So yan po yung location po natin ng center of pressure. Okay, so lastly, find the magnitude of the hydrostatic force on one side of the plate if it is raised 1 meter. Okay, so this problem, this requirement is very simple. So what we would be doing here is that we would just be raising the whole plate by 1 meter. So since it is, it was submerged by 1 meter, so ang gagawin po natin dyan, ikokopya po natin lahat. Actually, move po natin lahat pataas. So this is now what would happen. So, tataas lang po siya ng ganyan. Ang mag-iiba lang naman dyan is, of course, the bar H. So, for the bar H, so earlier, the bar H is 4.35. So, this time, instead of it being 4.35, kung tataas man po ito, of course, bar H would now be decreased by 1 meter. So, kung kanina po, 4.35 meters yan, right now, so it's updated, bar H now is now equal to 3.35. So mababawasan lang naman siya ng 1 meter. So this is now 3.35. So ito po yung bar H. So with that, dito isingit ko na lang. So P is now equal to, so 0.82 times 9.79 times bar H of 3.35 times area of 25. Then with that, P is now equal to, so 0.82 times 9.79 times 3.35 times 25. And our answer here is 672.33. So tama ba? So 0.82 times 9.79 times 3.35 times 25. Okay, so there.